Okay, so let us move on to another example, no? So, um, from our previous discussion, okay, I said that the principle of thermodynamics on work is based on the system, on how it done or how it do a work on external to them, to it, okay? So, yun. So, basically, that principle ni thermodynamics kay work is always conveniently illustrated by the um, piston, okay, or cylindrical piston, okay. So usually throughout our discussion, always natin minsan kasi sa kadalasan sa mga books, always nilang ginagamit si piston cylinder, okay, in order to illustrate the concept of work of concept of work by thermodynamics, okay. So yun, kasi uh, maganda siyang example actually, no? So that's why in here sa example natin dito, yun yung pag-aaralan natin, okay? Our purpose here is to illustrate the concept of work, okay? And the change of work by the piston cylinder, okay? So sabi dito sa problem, a gas in a piston cylinder assembly undergoes an expansion process for which the relationship between the pressure and volume is given by PVN is equals to constant. Okay? So pag PVN is equals to constant, it means that it it means that ang condition natin is quasi-static. Okay, so mamaya i-discuss ko kung ano yung ibig sabihin ng quasi-static. But take note that itong relationship dito is napaka-importante yun siya. Okay? So sabi dito, given dito sa problem natin, the initial pressure is 3 bar, the initial volume is 0.1, and the final volume is 0.2. Determine the work for the process in kilojoule if N is equals to 1.5 for letter A, and B for letter B naman n is equals to 1.0, and for letter C n is equals to 0. Okay? So ang aim natin dito is to find the work that is done by this system or yung gas na nasa loob ng piston natin. Okay? So yun yung hahanapin natin, yung work na nagagawa ng gas natin na nasa loob ng piston. Okay? So you have your solution, no? So meron tayong note here, sabi dito, a gas in a piston cylinder assembly undergoes an expansion for which PV pressure multiplied by volume raised to the power of n is equals to constant. So, ibig sabihin, quasi-static yung process na nangyayari dito. Okay? So, ang hahanapin natin is yung work na nagagawa ni gas dito kay piston. Okay? For when n is equals to 1.5, for letter A, for B naman is when n is equals to 1.0, for letter C naman is when n is equals to 0. Okay? So, yun. So, for schematic and given data, so meron tayong given schematic diagram here, no? So, ito yung condition natin. Ito yung initial condition, ito yung final condition natin. Okay? Dito yung final condition natin. So, as we can see here, the initial condition is the pressure. Okay, this is the relationship between the pressure and the volume. For the initial pressure, meron tayong 3 bar. Okay, for the final pressure naman, for the initial volume naman is meron tayong 0.1 meter cube. Okay, so this is the system. Okay, ito yung tinatawag natin na cylinder piston. So meron tayong piston here, tapos meron tayong gas here sa loob niya. Okay, so initial pressure is 3.0, initial volume is 0.1, tapos final volume is 0.2 as it given from the problem. Okay, so engineering model. Okay, so for engineering model, we have the first model is the gas is closed system, no? So tandaan natin, note that the gas is closed system, no? Closed system. For number 2 naman, the moving boundary is the only work made, no? The only work mode. Okay, for number 3 naman is the expansion is polyatropic process. Okay, yung kanina yung sinabi ko sa inyo na quasi-static condition is yun, another term of that quasi-static condition is polyatropic process. Okay, polyatropic process. Pag sinabi mong polyatropic process, the relationship between the pressure and volume is constant. Okay? So, let us go on to the analysis. Okay? So, sabi dito, the required values for the work are obtained by integration of equation 2.17. In this case, magagamit natin yung equation 2.17. What is equation 2.17? Yung equation 2.17 from your manual is yan yung work is equals to integral of from V1 to V2 integral of P dV evaluated from V1 to V2. Okay, so yan yung equation 2.17. So for us to be able to have the work done by this gas on the piston, gagamitin natin to siya. Okay, so yan. So for letter A, no, so when n is equals to 1.5, introducing the relationship, okay, we have P is equals to constant. Okay, gagamitin natin to siya. We have, kung i-rearrange natin tong P multiplied by V to the power of n is equals to constant, we have P is equals to constant divided by V to the power of n. So, mangyari is, yun, dito, no? We have P is equals to constant divided by V to the power of n. And then, substituting it into equation 2.17, in which this one, pag isa-substitute natin yun siya, mangyari is integral from V1 to V2 constant divided by V to the power of n dV. Okay? So, evaluating this one, we have constant, no? Distributing this constant here, no? Tapos, we have V2 raised to the power of 1 minus n. Kasi kung i-evaluate natin yung dV over V to the power of n, mangyari is V to the power of 1 minus n. Okay? So, substituting the limit, we have constant multiplied by V2 raised to the power of 1 minus n minus constant multiplied by V1 raised to the power of 1 minus n. Okay, so ito yung resulting ng integration natin, divided by 1 minus n. So just perform this integration here and you will the result will become this one. Okay, so the constant in this expression can be evaluated at either end state. Okay, so yung constant natin, itong constant dito, since hindi naman natin alam kung ano yung value nito, so pwede natin yun siyang hanapin, by using the assumption that constant is equals to P1 V1 raised to the power of n, or it may also equals to P2 V2 raised to the power of n, kasi constant nga eh. So pag sinabi mong constant, kahit saang state din siya, or kahit anong state man yun siya, constant pa rin, no? So that's why in here, constant is equals to P1 P sub 1 multiplied by V sub 1 raised to the power of n is equals to P2 V2 raised to the power of n. And kung gagamitin natin to siya, no? So mangyari dito sa expression natin is papalitan lang natin siya ng P1 V1, since the given quantity is yung pressure sa first condition natin at saka yung volume sa first condition natin. So yun yung ipapalit natin. Okay? So in here, we have constant is equals to lahat pala, no? Kasi because we have to be inconsistent with this value here, no? So you have dito, ang ipapalit natin is yung P2 V2 kasi meron tayong V2 dito. Okay, so we have dito naman, ang ipapalit natin is P1 V1 kasi meron tayong V1 dito. So that's why in here P2 V2, in here naman P1 V1. So simplifying this one, the result would be P2 V2 minus P1 V1 over 1 minus n. So ito yung pinaka-result actually. P2 V2 minus P1 V1 over 1 minus n. Okay? So okay. The expression is valid for all values of n except that n is equals to 1.0, and the case for n is equals to, okay, so this expression here is valid for all values of n except that when n is equals to 1.0. Okay, so itong equation na to, itong equation dito, itong expression na to, pwede mo siyang gamitin kahit hindi ka dumaan dito sa integration na to, if and only if your n is greater than 1. For n is equals to 1 naman, so another case na yun siya. Okay, so ipapakita natin yun siya sa letter B. Okay, so to evaluate this work here, the pressure at state 2 is required, no? So ibig sabihin ito yan siya, itong part na to, itong equation na to, ang given lang dito is si V2, si P1 at saka si V1 at saka si N. So hindi given si P2. So paano natin makukuha si P2? So again, makukuha natin si P2 by using this expression here. Okay? Itong expression na to. Yung P1 V1 raised to the power of N is equals to P2 V2 raised to the power of N. Okay? So solving for P2 here, so since given naman si P1, given din si V1, given si V2, so just substitute the value, so the resulting is 1.06 bar. Okay, so P2 therefore is 1.06 bar. Then after that, substitute the value for this case here, so saka mo makukuha yung work mo. So after that, substitute all the value, then converting it into kilojoule, kasi again, as I have said kanina, yung kilojoule is yan yung pinaka-standard na unit ng work in SI units. So that's why we have to convert that one into kilojoule. Okay, so that's why the resulting is 17.6 kilojoule. Okay, so by calculating this as a whole. Okay.